Welcome back, guys, with a brand new video. And today we are diving into the fascinating world of electronics passive filters, and sorry, more specifically, the twin P filter. In the previous videos, we already discussed the RL low pass filters, RC low pass filter, RL high pass filter, RC high pass filter, and also the filters with noise and crossover circuitry. Now we are moving towards the twin P filters. Now, if you are into electronics or audio engineering, you might have heard about different types of filters used to modify signals. The 20 filters, known for its unique characteristics, is widely used in audio applications for its versatility and effectiveness. Basically, to create a 20 filter, you will need a few basic components, as you can see on the screen, that resistors, capacitors, and you can say a sweep timer here, or a signal, and maybe an operational amplifier. And what's interesting about this filter is its ability to attenuate specific frequencies while allowing others to pass through relatively unaffected, like pass band filter. And let's put this together. The twin filter of two T sections connected in parallel here. If you understands by seeing this, two T twin filters, and each T sections includes resistors, and the other has two capacitors arranged in a T-shaped configurations. You can see here in this T twin filter, the two resistors and capacitors are attached in a T shape, and in this one, two capacitors and a resistor is attached in a T-shaped configuration, or arranged in a T-shaped configurations. Now here's the magic. By carefully choosing the values of these components, we can tune the twin T filter to attenuate or emphasize specific frequencies. It's an amazing tool for audio engineering, and especially in applications like audio equalization for noise reduction. Let's see it in actions. Here we have the 2D pin filters, as we already discussed. Now we have to notice that how taking the resistors and capacitors values enters the frequencies passing through. These features make it incredibly versatile for customizing audio signals according to our preference. And if you see that the waveform is mm, uh, constants here, but if you see the output waveforms, we are getting the uh, uh, different waveforms on the basis of the charging and discharging of these three capacitors. And here we're getting the outputs, and if we change values, here you see if the total capacitance is 53.1 UF, but when we are using in this configuration, it's become, you can say, half, almost half of this capacitors. And let me change the value of this resistance, as this resistance is limiting the current. So if I increase the values up to the 5 times, and you can see here the change in the output, that the voltages increases. And let me change this value to the above this, equal to the above this value at about 53.1 U already microfarad. And if we apply this, you can see here the change. Here we have changes the values. You can see the change in the output signals or output frequencies, and the voltages is here increases and decreasing at a very low rate because of the charging and discharging of this capacitors. Now its value is smaller, so quickly charging and discharging occurs, and that's why the output frequencies is the amplitude of output frequencies is a little bit increased. And how now, like this, we can uh, By notice how tweaking the resistors and capacitors values alters the frequencies passing through. So that's the Trinity filters, a powerful tool in signal processing, allowing for precise control for over specific frequencies. Whether you are a hobbyist or a professional, understanding and utilizing these filters can take your audio projects to the next level. Thanks for the tune and today. If you enjoyed this video, do not forget to like, subscribe, and hit that notification bell for more content. And if you require any type of assistance in your electrical and electronics project, you can ping me a message on my WhatsApp number, and also you can visit my Upwork and Fiverr profile. Thank you so much for watching the video.